Fundamentals of test automation. In this tutorial, I will explain you on a few basic things that you need to know regarding test automation. First of all, what does that mean by test automation?
Record and playback of manual test cases?
Many people assume that test automation is simply record and playback of manual test cases. Unfortunately, it is not.
Then what is it?
Test automation refers to two disciplines that requires different skills, techniques and expertise. Testing and automation.
Then, how these two disciplines come together?
In order to properly test an application, one needs to have an expertise of that application's expected behavior. For automation, you need to have an expertise in development together with the expertise on application. In testing, we focus on what to test, whereas in automation, focus is on how to automate those tests. Furthermore, for testing, you need to have well-designed test cases. For automation, you need to build test scripts. This is why test automation is not record and playback of manual test cases. It is something beyond that.
Having said that, what are the fundamental things that I need to focus on when I'm doing test automation?
First thing is maintainability. It is not always the case that an application only get new requirements. Existing requirements get redefined too and code gets rewritten. Application changes every day, so you need to be able to adapt these changes as fast as possible to your existing automated scripts. Not only that, you need to be able to integrate new features to your automated tests without affecting what is already there. In other words, this means that your automation tests need to be easy to maintain. It is not always a good idea to wait until an automated script fails, in order to identify a change. You need to frequently look into the code changes and identify the changes in advance, and adapt your scripts to those changes. In this way, your scripts will never go obsolete. To do this, your scripts must be organized in a way that they can be easily maintained. Second thing is optimization. Do not think that having more and more automated scripts is the best thing you can do. Having more test scripts will increase the time that you need to spend on developing them. Not only that, it will also increase the time you need to execute them as well as to maintain them. That is why the optimization is so important. If you optimize your tests, you will be able to get the job done without having too many test scripts to manage. A good test case will not go around the entire application or access wide variety of functions. Your test should be designed to map a specific business requirement. This will allow each test to be executed separately when a specific requirement changes. If you have cover a specific requirement in your test script, then it is easy to diagnose test results to identify which requirement has failed. When your test script is too long and spans across a wide area of the application, you will need more time to understand what and where it went wrong.
And because of that, I need to optimize my test scripts?
Of course. The third thing that you need to consider is independence. Precisely, independence of test cases. Independence refers to the degree to which each test case stands alone. The success or failure of one test case should not depend on another test case. If one of your test case tests a deletion of a record, it should not depend on another test case that creates a record. In this way, if the test case that creates a record fails, it will have an impact on the test that deletes record, as it is dependent on the record created by the first test case. The best thing to do here is add the record at the beginning of the test that deletes the record, so that it does not depend on any other test. State of data is the key to automation, so always keep your test data independent and make sure your data is in the correct state when starting the test. Apart from data independence, your tests must be context independent too. This means that, if your first test case fails and stops, then it should not affect the start of your next test case. For each test case, entry and exit points should be the same. For example, test might start by starting the application and it will stop by quitting the application, such that the next test case will continue again by starting the application. If a test case stops in the middle, then your script should take necessary actions to get the application to the required state by the next test case to begin with. Similarly, the result of one test case should not have an impact on the success or failure of another test case. In other words, test results should be independent. Let's say you have a test script where you do not expect to get an error message. But, if an error message is displayed due to a bug, then you should expect it and steps should be added to clear the error message. In this way, it will always ensure that your next test case will not fail due to that unexpected error message. Number 4. Modularity. In here, we refer to the modularity of test scripts. If you organize your test scripts in a way that matches to the structure of your application, then you can easily modify these scripts according to the changes made to the application. For example, you can organize your test script such that it contains separate scripts for each window of your application. Or, you can have separate scripts for setting and getting values of each GUI control. These scripts can be reused in your test cases. If you modularize your scripts in an efficient manner, it will reduce the redundancy of scripts as well as omission. But, keep in mind that modularity should not be taken to extreme. As mentioned before, modularity helps you to avoid redundancy by identifying common scripts that can be reused and shared by test cases throughout the entire test environment. Basically, you should keep modularity to a level that it helps you to quickly identify where to change. Fifth fundamental is the context.
What do you mean by context?
Context means the state of the application during playback of a test script. When executing an automated script, it expects the system to be in the same state that it was during the creation of the script.
Scripts cannot think? Isn't it?
Yes, of course. A test script does know anything other than what you have instructed it to do. So, it expects that the system will be in the correct state to begin and execute a test. If it is not, the script will fail. The simplest solution to beginning and ending context is to design all tests to begin and end at the same point in the application. For example, you can design all your tests to begin and end in the login screen. This will ensure that any of your test cases can be executed in any order. If you start and end each test case in different points of the application, then it will be difficult to recover from unexpected results. But when you control the context to begin and end test cases at the same point, you can use a common recovery function to get the system back to the initial state, such that the next test case can continue from there. Sixth point is synchronization. Application and the test script should be executed together. During the playback of a test script, there can be many reasons for the application to execute slower than it was executing when you were creating the test script. Heavier system traffic will increase the processing time, and the application may respond slower than it did previously. If your test script does not have a way to respond these fluctuations of application speed, it will fail, saying that the expected object did not appear on the screen. Synchronization is one of the issues that is unique to automated testing. A person performing a manual test instinctively waits for the application to respond or become ready before proceeding ahead. With automated tests, you need techniques to make this decision so that they are consistent across a wide variety of situations. This means that your scripts must wait for the application objects to become available and ready. If not synchronized, it will lead to failures of test cases. Last thing is documentation. Any automated test should have the ability to be executed manually. This is important to identify the exact defect when a test fails. In order to do this, automated tests should be properly documented. Documentation of tests may vary from comments to narrative descriptions stored within the tests or in separate documentation files. On the other hand, if you do not document your tests, then you will be the only person to understand what you have done in the script. To make it worse, after some time, Even you will forget what is in the script. At that moment, you will have to read the test script line by line to understand what it is doing. If it was described in documentation, then understanding a test script will be an easy task. Documentation is very important even when you need to transfer the scripts to a different automation tester. With adequate documentation, the new tester will make his life easy and understand the scripts in no time. If you do not know what exactly a script is doing or why it was created, you will be afraid to change or delete it. After some time, you will have a large number of unused scripts. This kind of mystery scripts can be avoided with proper documentation of what a script is expected to do. The more documentation is better. Assume that the reader has very less knowledge and provide as much information as possible.
I think it is better to put documentation in the script itself, isn't it?
Yes, the best documentation is inside the test itself, in the form of comments or description, so that it follows the test and explains it in context. With this, we have come to the end of this tutorial.